Good morning, everyone. My name is Magar Ahmed, Assistant Professor from GMD Arts, BW Commerce and Science College, Chennai. Today, I have discussed about second chapter, Problematic Soil and Soil Safety from TYBSC lecture second. In previous lecture, I have discussed about acid soil, formation of acid soil, introduction of problematic soil, effect of soil, acidity of soil, reclamation of acidic soil, effect of steam on acid soils. Today, I have discussed about new point alkali soil. In alkaline soil, formation of alkali soil. These soil have pH is greater than 7. The calcareous soil give alkaline reaction mainly due to presence of CaCO3 and MgCO3. While alkaline soil are one whose alkalinity varies with the sodium salt in the soil solution or both the presence of sodium clay or both. They are formed in the low rainfall and upward movement of rainwater, which helps in the accumulation of salt in the surface layer soil and arid and semi-arid region. These soils are available in semi-humid and temperature regions, especially where drainage is effective or where the underground water table is high. Under humid conditions, the soluble salt formed by the weathering of rocks and minerals are carried down and removed with the drainage water into the stream and finally to ocean. In case of defective drainage, they accumulate at lower layer and makes true soil alkaline. High water table also make the soil alkaline. Alkaline soil are also found on sea coast where salt deposition takes place. Artificial alkaline soil is produced. Canal water is used for irrigation to the movement of salt between the layers. In some cases, alkaline soil results from irrigation irrigation water itself having an excess of soluble salt, as in the case of soil, water, well, or due to the canal water passing through the saline region. Next point is classification of alkali soil. First is saline soil. Second, saline alkali soil. Third, non-saline alkali soil. I have discussed about one by one. First is saline soil. In saline soil, the soil which contain excess of sodium salt but the clay complex contain excess of exchangeable calcium or are known as saline soil or also called as solontract. The process of accumulation of salt leading to the formation of saline soil is known as the salinization. This soil contains chloride, sulfides, nitrates of Na, Ca and Mg. Some, some soils also contain K salt. You know that K means potassium salt. Soluble carbonates are absent in such a soil. That means in saline soils, soluble carbonates are absent. This soil is also known as white soil due to the presence of sodium chloride and Na2SO4 which impart white color to the soil. Sometimes the color is brown due to the presence of CaCl2 and MgCl2. The pH of soil is between 7.5 to 8.5. ESP is very low. EPS means exchangeable sodium present percentage. EPS is calculated by this formula: 100 into exchangeable sodium divided by CEC, where when EPS is exchangeable sodium percentage, ECEC is cation exchange capacity. The clay particles of the soil are granulate but do not have well-developed structure. It has high salt concentration. It is also permeable to water and air. Next is saline alkali soil. In saline alkali soil, on accumulation of soluble salt in a soil over a prolonged period, Na is the predominant cation in the soil solution while plant absorb calcium, magnesium and potassium. Sodium is not an essential nutrient except for a few crop plants. Due to the evaporation of moisture of soil or absorption from plant, CaCO2, uh, CaCO3 and MgCO3 or CaSO4 get precipitated, thus increasing the Na concentration. When the concentration is above 50% of the total cation, Na plus ion replace the exchangeable Ca2 plus and Mg2 plus ions of the clay complex due to the high concentration. Though the reaction is reversible, Ca salt are removed in drainage water. As soon as they are formed, thus making the reaction unidirectional. The process of converting normal soil into the alkali soil is called as alkalization. The soil may contain Na clay and excess of salt or only Na clay with no soluble salt. If the soluble salt are not reached out due to the insufficient rain, then the soil contains sodium clay and excess of sodium salt in solution. It is known as alkali soil. Next point is non-saline alkali soil. It is a type of alkali soil. When soluble salt are removed by leaching as a result of the increases in rainfall or due to the fall of the water table or by irrigation water washing them down or for any other reason, it gives rise to non-saline alkaline soil. It contains colloidal complex saturated with exchangeable Na and insoluble salts. The soil changes depends on the presence or absence of free CaCO3. If reaction is Na clay plus CaCO3, Ca clay exchange with Na and Ca clay and plus Na2CO3. Free Na2CO3 reconverts the exchange complex into Na clay due to low concentration of soluble CaCO3. Due to the presence of Na2CO3, soil or organic matter makes black solution which on spraying form black patches on the ground surface with black deposits on the soil particles. This soil is known as black alkali. The clay gets deposited in the lower layer, making them impervious, having prismatic or columnar structure. These soils are called as solons. The process of development of these soil from the saline soil is known as salinization. Tolerance by plant. Both saline and alkaline soil are harmful to the plant on account of the excessive concentration of soluble salt in the soil solution in one case and exchangeable Na or both in the other. The large amount of salt in the solution increases the osmotic pressure and reduces the uptake of water which causes plasmolysis. Plasmolysis increases the concentration of solution until all the functions of plant collapse completely and the plant finally dies. Growing plants under such a condition are die due to lack of sufficient water. Plant tolerance varies also with the age of plants. Plants that have deep root systems are able to tolerate salinity better than others. Growing plants in the sandy soil are to the tolerate a greater concentration of soluble salt than those in clay or both fine structured soils. Climate also influences salt tolerance by crops. Growing plants in arid and semi-arid regions are able to tolerate greater salt concentration than those in semi-humid and tropical regions. Calcareous soil. Calcareous soil are formed in the warm temperature and semi-acid region where rainfall is low and evaporation is high. Soil profile of those soils contains calcium carbonate and magnesium carbonate in very proportion and precipitation is not sufficient to leach out of the basic product of weathering. Due to the evaporation of water or absorption of water by plants, calcium is precipitated as CaCO4 or CaCO3 and magnesium as MgCO3. If the soil body is highly permeable, these salts accumulate in parent material from which soil is formed. Sodium and potassium salts are either deposited in the lower depth or removed from the soil completely. Calcareous soil are highly buffered. Carbonate present in them get hydrolyzed due to the presence of water. Reaction CaCO3 plus H2O molecule, that means water, it gives Ca2 plus. 2 plus is oxidation state of calcium plus OH minus. Next, CO3 plus water molecule, that means H2O plus CO2, it gives Ca in bracket HCO3 2. CaHCO3 2 gives calcium 2 plus hydrogen plus HCO 2 plus 3 plus CO2 minus 3. Thank you.